Hi, welcome to BFS Search Traversal algorithm. Here it is used to find shortest path from the given graph. It is using the queue data structure to visit all the nodes to keep track of the path. Here we will give the input data of the graph using adjacency matrix or adjacency list. Then we will create the queue to fill the vertex of given graph. From that list of vertices we can select any vertex from the root. I mean, that is, whichever vertex you want to select, you can select from the graph. So before selecting the vertex, you should identify the given graph is a directed graph or undirected graph. Okay, if it is undirected graph, then you can select any node as a root vertex, I mean source vertex. But if it is the directed graph, you have to select the vertex as a source that should have path to all the vertices in the given graph. Suppose if you select the B as a source first vertex, there is no other outgoing edge, that means there is no adjacent vertex to this B. So if you select the B, then you cannot move from B to any other vertex. So whenever you are selecting the vertex in the directed graph, that should have path to all other vertices in the given graph. For example, if you select the E, it is having the path to G, then through the G you can visit the D, from the D you can visit the F and C, and from the G again you can go for H and B and A. So like that you have to select the vertex. Then whichever vertex you are selecting, that can be inserted into the queue. Then based upon that you have to find out the adjacency vertices by using either adjacency list or adjacency matrix, that we will see now by using the Java code. So in the Java code, first we have to pass the number of vertices. Here I am creating the number of vertices are 4. The vertices are I am giving with the edges. Here I am going to add the edge between 0 to 1. So here I am adding the edge 0 to 1. So for this I am calling the method add edge. So when you are calling the add edge, you are passing two vertices. One is the 0 and another is the 1. So we are passing the 0 and 1, then we are making that edge by adding in this into the adjacency list. So adjacency list, here V is 0 to W1, we are adding the edge. So the adjacency list is created by using class graph. Here we are defining the number of vertices, and we are going to create the adjacency list by using the linked list concept. So here, so this is the adjacency list for given graph. I have used the linked list to create the adjacency list. So we are using the constructor for the graph class. We are passing the value v, number of vertices. Then here we are creating the object for adj for number of vertices 5 or 4, whatever number of vertices we are giving. Then we are creating the, for each vertex we are creating the list. You look at this, for 0 we are creating the list, 1 we are creating the list. So like that for all the vertices we are creating the adjacency list. Then after adding the edge to 0 to 1, right, so we are creating the edge for the adjacency node. Also for the 0, 1 is one adjacent node, and then we are adding next edge from 0 to 2. So here from the 0 to 2, this edge we are adding, and this edge is calling by method add edge. So here the second time we are calling this 0 to 2. So 0 to 2 added. So from the 0 to already 1 is there, so now 2 is added, right? Then again like that we have to add 1 to 2. So 1 to 2, here this edge is added. Then for that also we are calling the method 1 to 2 by using the add edge method. So one is the v and w is 2, so we are adding the nodes into the list, adjacency list. So now for the 1, the 2 is the adjacency node. So like that, for example, for last add edge 3 comma 3, so we are adding the self loop. So here for that also we are calling here uh, v is 3 and w is also 3, right? We are adding into the list. So here for the 3 we are added the adjacency node. So after that we are calling the BFS method by passing source vertex. So here I am selecting the source vertex that is having the path to all the vertices given graph. You look at that, from the 0 to 1 you can move, 1 to 2 also you can move, or 0 to 2 also you can move this path, and 2 to 3 also you can move. So you can visit all the vertices. So now I am passing the 0 as a source vertex. Once I am passing the 0 as a source vertex, we will get this output. So here I am passing the 0. So here we are making that boolean variable initially visited. Here the linked list based queue is created. Then here now visited of 0 I am making true. So now this is the table, table for reference, visited table. So boolean variable, so I am selecting 0 is visited. Now I am adding that s0 into q. So added 0 into the queue. So this is the queue, linked list based queue. You assume this is like a linked list. And now we are going to check the q dot size not equal to 0. You look at that, the number of elements in the queue is not equal to 0. Yes, it is having the element 0, so it is 1. So it is true. So when it is true, we have to check the q dot poll. That means we are deleting the 0 from the queue, right? So we are deleting the 0 from the queue. So we are deleting the 0 from the queue. Now that s is printed. So now that s is, what is the s? 0 is printed. So 0 is printed in the output. So this is the 0 we printed in the output for the traversal, right? Next, here after that we have to check the adjacents of 0. So adjacents of 0, is it having the list? Yes, you look at that, in the adjacency list we are having the adjacency of 0. Yes, if it is having the adjacency of 0, so you look at that, I has next, I is the index. So this is the 0. So 0 dot has next. Yes, I dot next we are assigning into the n. So we are, if it is not visited, you look at that, still the, what is the 0's adjacency? 1. So from this list adjacency of the 0 is 1. It is not visited. So if it is not this is the table we are checking, it is not visited. Okay, if it is not visited, then we have to make that visited of 1. So I dot next is here, we are taking 1. Okay, so 1 is the n here, not visited, we are making visited of 1 equal to true. So now you look at that, we are making that 1 is also making visited equal to true, right? After that we are adding that 1 into the queue. We are adding that 1 into queue. So now we are adding that 1 into the queue. So now we have added the 1 into queue, right? So after that, now this is over, right? Again we are going back, right? So now again, now you look at that, add the I is still 0, right? Here, so now is it have next. So you look at that, I is now here, we look at that, in this place it is a 1. Okay, it is a 1. So from this we are checking, right, it is has next or not. If it is having it, if it is has next, right? So now we are checking the, look at that, 1 is having 2, right? So if it is having 2, we are making 2 is also visited or not. It is not visited. Then we are making that 2 is here visited. So from this adjacency list, the next. Okay. So we are making that 2 is also visited. Now after 2 is visited, we are checking the we are adding that 2 into q. Okay. So now 2 is also added into the queue, right? So 2 is also added into the queue. Then again we are going back. So here now I is 2. Okay, so now still it is having the any vertex. So here in this adjacent cell list there is no vertex from the 2. Okay, so then you can complete. Okay, so now we are checking the queue. We are checking the queue, right? So when you are checking the queue, so this while loop is not completed. Okay, so this while loop is now over. After that, one more while loop is there. That while loop is not completed now. So we are checking the while loop this. So now q dot size of not equal to 0. Yes, it is having the values 1 and 2 are there. So now we are checking q dot pole. That means we are removing the 1 from the queue. After removing the 1, we are printing that 1 into the output. So we printed the 1. Then we are after printing we are checking I is now 1. Okay, so from the 1 we are checking is there I dot has next. So 1 is we are now I is 1. So 1 is having the list or not. You look at that one here one is having the next node or not from the adjacency matrix. So from the adjacency matrix when you are checking the I has the next node. So here one is having 2 as a adjacency node in this place. So we are checking, right, the 2 is visited or not. Okay, 2 is visited or not. So based on this, so I dot has is here 2. We are checking 2 is not visited or not. It is not visited. You look at that 2 is already visited in this place. This is the reference table. Okay, 2 is visited. So if 2 is visited, then this condition will be false. Okay, so for 2 the condition will be false. So what will be happen? This will not execute. So it will come to the next this while loop. So still q dot size is we are having number of element 1. So if it is number of element 1, you are deleting the value 2. Okay, so now we are deleting the value 2 from the queue. Then we are printing the 2 in the output. So we are printing the 2. Then now again we are checking the I. What is the I here? 2. So 2 is the value. So for the 2 if we are having the adjacent vertices or not. So now for the 2 look at this, we are having the 0 and 3 in the adjacency list in this list. So we are checking first 0. Okay, so 0 here is it visited or not. So for the 0 first, is it visited or not, but 0 here it is already visited, so this will be false. Then it will go back. Next again it is checking for what is the next number. The next number is here 3. Okay, so 3 we have to check visited or not. So 3 is not visited, so we can make that as a visit. So 3 here the 3 is not visited, it is true. So you will make that visited of 3 will be true. Okay, so now you are making that as a visited is true. Then now we can add that into the queue. So now 3 is added into the queue right here. Then after that that while loop is again we are checking is there any next value available. I guess next value or not in the next loop. So there is no value. Okay, for 3 dot next is nothing is there. So we can come out of the while loop. Now we are checking the this in outer while loop. In the outer while loop here we are having 3 is the size. So 1 not equal to 0. Yes, it is true. So now we are taking out, that is deleting that 3. So now we are deleting the 3. So after deleting the 3 we are printing the 3 in the output. Yes, it is also printed. Now we are checking for the 3. Then for the 3 dot has next. Yes, 3 dot has next is from the adjacent list 3. Okay, so now 3 is there. We are checking for the 3 it is visited or not. So it is false. Not visited is false because it is already visited in the graph. Okay, so now this is also false, then if it is false, it will come out of this inner while loop. So outer while loop is this one, q dot size. So q dot size is now empty, right? Look at that, all the elements are deleted earlier, so now it is empty, so you can stop the algorithm. So given list, it is printed 0 1 2 3. You look at that path. So from the given graph, the path is 0 1 1, then 0 2 2, then here 2 2 3. Okay, this is the path. So like that, when you are using the uh, vertex 3, okay, this is the vertex 3. When you are passing gfs of 3 here, then it is starting with from the 3, so 3 to 3 only, 3 to 3. There is no other possibilities, no other outgoing edges are there, no other adjacency list is there. From the 2, if you take the source vertex from the 2 to 2 to 0 0 to here, again we can go to the uh, we can go to the 1, and we can from the 1 and from the 2 also you can go to the 3. First 3 2 and 3 we are visiting. Here 0 from the 0 from the 2, first 0 is visiting as per the adjacency list. You look at that, from the 2, 0 and 3 is visited first, so that's what printed here. 2 and from the 2 0 and 3, then finally from the 0 to 1, that's what printed here. So this is the way to find out the shortest path by using Java code for breadth first search traversal. Thanks for watching.